Hello everyone, Mr. Lloyd here, your friendly D&T teacher. Now as you know, we have progressed quite far into our key tag holder project in the journal. Many of us reaching page 11, and some of us has cut out the mock-ups, page 13, and transferred the design onto your acrylic, and some of the classes have actually started cutting. Okay? So what we are doing here is to focus on performance tasks, so that when you complete your prototype, you can consider installing what you learned on page 14, the performance task of creating a very simple parallel circuit LED output device, and you can actually mount it or install it onto your actual prototype. Okay, that will enhance the use of your key tag holder. So briefly, looking at page 14, right? You will need to draw this circuit diagram. So please draw it with straight ruler. Alright, the lines here represents the wires. Over here is your button cell. You will be given one button cell of 3 volts. So please label here as 3 volts. And take note the longer line, vertical line that you see, and the shorter line. The longer line is the positive side, or we call it the anode. The shorter side of your battery, which is actually the one behind this button cell here, is your cathode, the minus. So by conventional current flow, electricity or current will flow out through this wire and passes into the first LED. In this example, you can see it's yellow LED. You have a choice of 2 or 3 colors, and of course through the second LED as well. Okay, in this case, it's the red LED. What happens is the current continues to flow and goes back into the cathode or the negative end of the button cell, and the current or the electricity continues to pass through until the button cell chemical energy in it is flat, or that you remove the contacts. Okay, take note that there is no physical switch here. So in order to turn on or switch on both of LEDs, right, you just need to move the wire. One wire will be in contact with the positive side of your button cell. The other wire will be below it, okay, on the other side of the button cell. So when these 2 wires are in contact with both sides of your button cell, current will flow. Okay. So also you need to take note that we will be wrapping the wires around the ends of both the LED legs, okay, or we call it the leads. Legs or leads are acceptable. But you need to know that the LED has polarity. What it means is just like your button cell, there's a plus and minus. So for your LED, right, there's a plus and minus as well. The plus side of the LED is usually the longer leg. Okay, I repeat. So this side is the longer leg. So it matches to here and here. This is the longer leg. Okay, it will be like your middle finger and your index finger, right? The middle finger is the longer leg. Okay? So likewise, the shorter leg will be on the other ends here. So you connect the wires together and then it comes down. So if you look at this circuit diagram, the LED, first LED is the same side by side with the second LED. So this is what we call the parallel connection. So we will now dive in straight into the practical section. Hello everybody, my name is Mr. Lloyd. I'm your friendly D&T teacher. This recording is made on a Saturday. And it so happens that the contractor for grass cutting is here. So in order for you to hear me clearly and there's no one else in the workshop, I shall remove my mask. For your performance task on page 14 of your key tag holder Secondary One design journal, you will see that there are 2 photographs of a simple circuit. In this case, it's a parallel connection of 2 LEDs or light emitting diodes. So we're going to start off your performance task with preparing the button cell. Each one of you will be provided with a button cell. On the cell itself, there's a positive and a negative. The positive is also known as anode. The negative is known as cathode. The positive is represented with a plus sign, and the negative is represented with a negative sign. But sometimes on the button cell, you only see the plus. Once you know the plus, the other side is the minus. In this exercise or performance task, your positive side of the button cell will be facing upwards, okay, towards you. Now these are thin wires. They come in different diameter sizes, right? It can be as thin as your pair of strand. We are talking about somewhere between the diameter 0.1 to 0.2 or 3 mm. So they are pretty thin. And if you go for institutions of higher learning and you go into electrical electronics engineering, you might encounter prototyping, electronics, and then you got the wire wrap, very fine components. So these are the kind of wires that we use. So if you can't see very clearly, you may have to use a helping tool called the magnifying glass. Right? So for me at my age, I have to wear my reading glasses. Otherwise, I cannot see the wire. So you're provided with a short length of the copper wire. Generally, the copper wire is its entire length of the wire is coated, so it will not short circuit. So in other words, if you want to connect to a component like the LED here, alright, the LED here, you will have to use sandpaper, which we will provide you, to expose the end of the wire which you will be coiling around the leg or the pin or the lid of your LED. Of course, alternatively, we do not recommend in school that you can use the penknife to scrape off the layer of coating at the end of the wire. To make it safer, you can use a pair of scissors, the blade, and scrape the surface, okay, towards the end of the wire, not the entire length. So we're going to lay this first wire about, on paper is about 5 centimeters long, and you're going to expose the end of this wire, and you're going to wrap it round, okay. This leg of the LED is actually the longer leg, okay, or the plus. When you look at your LED, you will see that one of its legs is actually longer than the other. So the longer leg is the positive. So once you tie that ready, okay, you can use a second shorter piece of wire and do the same, expose the end, tie it, and go to the second LED. Okay, so this is your LED 1, this is your LED 2. So you do the same, you coil around it, and you just use your thumb and your index finger to meet the pressure so that the wire hugs the LED. Now, this is just temporary, okay, because if you use strand, a little bit of strand, you can pull the wire away from you. But for your level, if there's time, we will teach you soldering. If not, you will just coil it around, okay? Of course, you can consider using scotch tape to tape it around, just to hold it a little bit better. So, first wire, second wire. The third piece of wire, I will use red. So you can see you coil, and you repeat the process, and you point down to the first LED. This time round, these two legs are the shorter leg. And last but not least, you coil the exposed end of a longer wire, and you pull it down towards your button cell. Okay, so for the blue wire here, it's actually going to be in contact with the positive side of your button cell. The negative wire will go below or beneath the button cell. Okay, so when we place them side by side, chances are there's no permanent contact, so you don't see the LED light up. So only when you press the plastic covering of the button cell packaging, right? Alright? Or if you don't have the packaging, you just need to use a scotch tape and hold the wire at this end. I'm going to use green. You use the scotch tape and hold here, and when you press this end of the wire on top of the positive side of your button cell, your circuit will close and current will pass through, or electricity will pass through, lighting up both of your LEDs. So we're going to jump into the practical itself.